Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Counted on our fingers and toes. Now you're here to stay.
Okay, we're doing more trig proofs. So you're going to use all your identities that you've learned so far for these trig proofs. So looking at 9A4, I see that I have a bunch of squares. Anytime I have a bunch of squares in the problem, the first thing that I always look for is, can I use my Pythagorean theorem trig identities for that. So the one thing I see here is I have a sine squared plus cosine squared. I can rearrange the problem as long as I keep the sign in front of the number stays with the number. Like this negative stays with the tangent squared. Positive stays with the secant squared. Positive stays with the cosine squared. So I could rearrange this if I wanted to. Say sine squared plus cosine squared minus tangent squared plus secant squared. Okay, what does sine squared plus cosine squared equal? 1. That's in Pythagorean theorem in trig notation. So that is 1. Don't just cancel it out and be 0. It's 1. So I can change that to 1. And then the general rule after that is change everything into sines and cosines. So I'm going to go ahead and change everything into sines and cosines. So I'm going to change this. Tangent is sine over cosine, so that would be sine squared theta over cosine squared theta. Plus secant is 1 over cosine, but it's a squared. Since that's a secant squared, that would be a cosine squared, is equal to 2. Now I'm adding fractions. I can make this 1 into a fraction by making it over 1. 1 over 1. I'm adding fractions. What do I have to do to add fractions? Have a common denominator. I already have a denominator of cosine squared here. I need a cosine squared here. So this just needs to become cosine squared over cosine squared. Okay, for ease of rewriting on the board, cosine times 1 is cosine, so I'm just erasing that. So this whole fraction just becomes cosine squared over cosine squared. Now that I have a common denominator, then combine my numerator. Cosine squared theta minus sine squared theta plus 1 all over cosine squared theta is equal to 2. Remember, my goal is to show that the left side is equal to the right side. Okay? Again, anytime I have a bunch of squares, my cosine squares or sine squares, I look at the my trig notation. Okay, so the Pythagorean theorem and trig notation. So is there anything that I can change? And you can see I'm looking at my formula sheet. Is there anything that I can change there? So if we have here's a negative sign. So basically if we had 1 minus sine squared. Okay, I'm going to rewrite this. So if I had cosine squared theta plus 1 minus sine squared theta, just so you can see this. All I did was just rearrange this. I still have a positive 1 there and a negative sign there. What is 1 minus sine squared theta? If you look on your formula sheet, it is one of the forms of the Pythagorean theorem. So 1 minus sine squared theta can be replaced with cosine squared. Okay, I'm right off to the side. I don't know if you can see that. Cosine squared is same as 1 minus sine squared theta. So I'm replacing this whole thing right there with cosine squared. So then I'll have cosine squared theta plus cosine squared theta all over cosine squared theta. 1 of these plus 1 of these, this is like a coefficient of 1 in front. 1 of these plus 1 of these is 2 of these. Now what happens to your cosine squares? They cancel out and you're left with 2, and then the right hand side is 2. So we proved that the left side does equal the right side. You have to use all your identities and just look at your formula sheet on what can you replace. Alright, let's look at 9A6. I don't have any squares in there, so I only look at Pythagorean theorem and trig notation if I have a bunch of squares in there, because that has a lot of squares in it. Since I don't, then the first step I usually go to is changing everything into sine and cosine. Okay, so changing this top one, 1 plus cosecant is 1 over sine. Now doing the bottom, 1 minus cosecant is 1 over sine. My right side is already in sine, so I'm not going to change it for right now. I'm just going to work with my left side and see what happens. This is like saying 1 over 1. Adding fractions, so what do? Make a common denominator. This denominator needs to be sine. So this would be the same thing as saying sine over sine. Same here, sine over sine. So over here, basically I would have sine over sine plus 1 over sine. I probably would normally skip this step on my paper. I get real bad about not writing in my thetas as well. All over sine theta over sine theta plus 1 over, that's a minus, sine theta. In the top I have a common denominator, so I can combine my numerator to say sine theta plus 1 all over sine theta, all over in the bottom, combining my numerators, sine theta minus 1 all over sine theta. Now that I've simplified the top and the bottom, then I have a fraction divided by a fraction. Flip the second and multiply. So sine theta plus 1 over sine theta times, flipping the second one, that becomes the numerator, that becomes a denominator. Multiplying fractions, you can cancel when you're multiplying, not adding. So those cancel. These are different signs, so they don't cancel. That sine theta plus 1 is married. Sine theta minus 1 is married. Don't cancel this sign with this sign. They are connected by that addition or subtraction sign. So then what you have left is sine theta plus 1 all over sine theta minus 1. When I get down to this point, I look at the other side to see if I need to change it. I don't. So I see that it matches, and I've made the left side equal to the right side, so I've proved it. Okay, we're looking at 9C1. So generally I just kind of look at the problem, the whole problem first, to see what I can change before changing everything to sine and cosine. I see here that I would probably get rid of this cofunction and I would put something in its place, and then I'd put something in this place. Anytime I see a 90 degrees minus theta, I'd rather change it to something simpler. Same here. And then I also look at this and say, okay, is there some sort of Pythagorean theorem and trig notation that I can change? So let's just start right here, okay? So I'm not going to do anything to this tangent theta yet. So cosecant of 90 minus theta, that is a cofunction. So cosecant of 90 minus theta is equal to secant of theta. If you're not sure, you can look at your formula sheet, because secant of theta is cosecant of the other angle. Okay? So I'm going to change this as well. Cosine of 90 minus theta should be sine, because sine of theta is cosine of the other angle. Okay? All over this. Okay, now let's go back to here. So now I'm going to go to the rule of change everything into sine and cosine. Tangent is sine theta over cosine theta. Remember, when you see tangent theta, secant theta, that's implying multiplication. So I'm just going to put my dot to show multiplication. Secant is 1 over cosine. Okay, I can't do anything to my sine theta there. But can I change this? 1 minus sine squared theta. Okay, looking at your formula sheet, this is Pythagorean theorem, it's just a different form of it. So 1 minus sine squared theta is the same thing as cosine squared theta. Now go back to the left hand side. Multiply your fraction out. Sine times 1, sine. Cosine times cosine, cosine squared theta. And look, lo and behold, I'm done. As you're working these out, just keep looking back from the left to the right and see where you're at. See, are you getting closer to where the left side is equal to the right side? So I got down to where I proved that the left side is equal to the right side, so I can stop there. Okay, we're looking at 9D2. As you can see on this one, that everything is already in sine and cosine. I don't have any squares over here. Over here, things in sine and cosine, but I do have a square. So then you can look at, okay, is this something to do with Pythagorean theorem in trig notation? No, because there's this 2 coefficient right there. So what do you do then? Sometimes on these, it's not just about changing things, but you can actually multiply something to it. Sometimes you can multiply by the conjugate. You can multiply the denominator by the conjugate, because when you multiply by conjugates, when you multiply conjugates together, you get difference of 2 squares. So if I multiply by the conjugate of this, remember conjugate looks exactly the same, except opposite signs. So cosine minus sine is the conjugate of cosine plus sine. But whatever you do the denominator, so I'm picking the conjugate of the denominator. Whatever I do the denominator, I have to also do to the numerator. So I'm multiplying the numerator by the same thing. So if I put parentheses around those, what I am doing is I am foiling this parentheses times this parentheses. It's the same thing that you learned in algebra, except now we're just using trig functions, okay? Foiling, first, outside, inside, last, okay? So, cosine times cosine, cosine squared. Cosine times a negative sine would be a negative sine cosine. Now let's do the inside. Sine, a negative sine times a cosine would be negative sine cosine. And then a negative sine times a negative sine, negative times a negative, positive sine squared. That was just all foiling out the top, okay? I don't believe we're going to change the right hand side on this side. We're just going to work on the left side. Now let's foil out the bottom. Cosine times cosine. Cosine squared theta. Cosine times a positive sine, positive, and I'm going to write my signs first. Doesn't matter if you write sine, cosine, or cosine sine. Multiplication is commutative. Negative sine times cosine would be negative sine cosine. Let me get my thetas in there. Negative sine times a negative sine, a positive sine, and negative times a positive is a negative. Sine times sine, sine squared theta. Looking at the numerator, I have cosine squared. Look, see if you have anything that you can combine. And negative sine theta, cosine theta. Negative sine theta, cosine theta. These are exactly alike, so I can combine them. Negative one of these and negative one of these. I'm in debt 1 and in debt 1 means I'm in debt 2 of those. I'm just simplifying where I can at this point. Now looking at the denominator. Positive sine, cosine, negative sine, cosine. Those cancel each other out. So then the denominator, I have cosine squared theta minus sine squared theta. Okay, now let's go back to the numerator. Anytime you have squares, look for Pythagorean theorem and trig. Cosine squared plus sine squared. What does cosine squared plus sine squared? That equals 1. So now I can replace that with 1 minus 2 sine theta cosine theta. I'm getting really excited at this point. You know why? Because my numerator matches the right hand side. Okay? So I've got my numerator to match, but I need my denominator to match. Well, sine squared, or cosine squared minus sine squared does not equal 1. Don't do that. So what can we do? Okay, we're wanting it to be 1 minus 2 sine squared. So that tells me I need to leave my sine, because the right hand side is sine. So I need to get rid of cosine. Can I replace it with something? Yes. Look at your, look at Pythagorean theorem and trig form. What does cosine squared equal? Cosine squared equals, let me rewrite my numerator so I don't lose anything. Okay, numerator is going to stay the same. I want to replace that. Cosine squared is the same thing as 1 minus sine squared. Okay, so cosine squared equals 1 minus sine squared. That equals cosine squared. So that's that. Now I still have my minus sine squared. Okay, so still have my numerator. Now looking at my denominator, can I combine anything? These two are the same kind, so I can combine them. Negative one of these and negative one of these. I'm in debt one of these and in debt another one of these. So that means I'm in debt two of these. Now, this looks like my right-hand side. So I can just rewrite my right-hand side. I don't normally write my right-hand side unless I'm going to change it. So this is kind of the same thing. This comes all the way down to right here. But I do suggest that you get down to the bottom and write to where you have one side equals the other side. These two should look exactly alike, and you should be doing legal moves on every step in between.